Hi, my name is Kayvan Khasrari and I'm a Technical Product Manager for Synopsys Ethernet IP. Here we are at ECOC 2024 Frankfurt, Germany, and at OIF booth we are showcasing our 224 gig IP test chip in action. Here we have our 224 gig test chip sitting underneath the socket, and through RF connectors we are generating a PRBS pattern inside the test chip and sending it to different type of channels. You can see the before DSP raw ADC format, as well as the DSP after the equalization. After the DSP we are able to open the eye completely fine, and we are showing the BR performance. VSR is sitting in there, the same performance, very good performance, exceeding the expectation from the standard. Here we have our Synopsys 224 gig test chip IP under this socket. Test chip is sending PRBS pattern at 224 gig data rate, going through different MCBs and DAC channels as well as ACC channel. We are working with our link partner test equipment, basically their scope, to show the performance of the eye after a reference receiver.
We're excited to be working with Synopsys at the OIF booth to show the progress. Thanks to the LR5 being driven across a 40 dB channel through a multi-lane logic compliance board in a passive DAC, we're able to show a very clean open eye thanks to some reference equalization with the multi-lane 67 GHz sampling scope.
Here we have Synopsys 224 gig LR5 IP test chip sitting under this socket. We're producing a PRBS pattern going through a module compliance board in here, and through an active copper cable to another module compliance board, and to a scope from an OIF link partner.
Over here we have a Keysight DCA sampling scope, and what we have set up is looking at test point 4. Test point 4 is at the far end of the channel here. So we have an active electrical cable, AEC, is drawing a little bit of power. It's actually probably one of the more efficient means of getting a cable to interconnect based on copper. And the challenge is looking at the electrical properties at the end of this cable to see if they pass your specifications or not. And we're showcasing a reference receiver, reference equalizer on the scope here. This is a CTLE followed by a FFE and a DFE. It's a 3 equalizer combination that we tune, and we have basically a composite tuning algorithm that gets the optimum set of coefficients in the equalizer. It allows you to open up the eye of an otherwise very closed eye diagram. Typically the losses at this point in the channel are on the order of 36 to 35 dB, quite high loss, and it takes a little bit of effort to get the eye open again. But in this case, we're able to measure an open eye, and we're doing a penalty measurement and EECQ measurement at this test point.